Hey everybody, welcome to Oregon State University's Permaculture Design Pro. This is the spring and summer session. This is office hour number 5, and Steve has a question for us. Steve, go ahead.
Yeah, just with respect to one of the teaching videos, Andrew had spoken about stacking functions when we're considering, our design and that sort of a thing. So I just wanted some clarification with respect to what that was, maybe an example or two, just to make sure I'm not.
Yeah, absolutely. So stacking functions is a design directive, and stacking functions means that an element within the system is serving multiple functionalities. So usually in urban situations, we'll have pathways that are also water harvesting earthworks, and they may even distribute water throughout the landscape. And then if we fill them with mulch, they can turn into earthworm farms and soil producing elements within the landscape. And then if we decide to inoculate them with mushrooms, let's say, now they're actually cropping beds. So that pathway is actually serving multiple functions, or we say that it's stacking functions. If we look at some of the in-person PDC design exercises that we'll do, is we'll take a number of classic elements within a landscape and sort of a regenerative permaculture, urban or rural landscape, and we'll get people to mix them around to see if it makes sense to put the chickens on top of the compost or under the compost, or we it's a random assembly, so we put them all together. And colleagues of mine, Hatchet and Seed Contracting over in Victoria, have a great video about how in their chicken coop, they put the compost in the chicken coop so that way the chickens can pick through it first. They also defecate in it and urinate in it. And what they find is that their compost gets produced quicker, but it also goes through one more cycling of having the chickens enter into it. So that way it produces a bit more eggs for them and a bit more meat for them through the chicken. So basically it's having one element serve many functions within a landscape. Any follow-up questions about that, or does that make sense?
Yeah, it makes sense. It's like everything, right? You have this information and then it's about implementation, So, okay, where could I see, for example, like take that idea and, things that I'm doing right now in terms of, planting or organizing, different things, like even with respect to my compost piles, to use that as, to kind of go from your example is what can I do differently there that maybe may help to kind of just serve a few more purposes.
Mm-hmm. Yeah, and I think for something like you in Lake Country, when you're taking a look at that biome in particular, having that compost in a place to where it gets a little bit of sun, so it warms up a bit, but generally it has some shade, so that way it can go through its meso and its thermophilic processing. But it's also close to the house, so that way you can connect with it. Or if there's a way to integrate it with animals, that makes good sense. But if I remember correctly, your property kind of slopes up in the backyard. Is that right?
Yeah, it slopes up from, we're kind of semi-lake shore here, so Okanagan Lake, and so yeah, it slopes up from the lake quite significantly, actually. It's probably 20 to 30 feet or so. I haven't done the exact calculations, something I need to do, but
Yeah. So, as you're looking at design throughout the rest of the course, especially with the water assignment that's coming up, starting to think about, well, if I harvested water at the top of the landscape and then had it being harvested all the way down, if I harvest that water, what can that water do now? Is there an element where that water can be put into practice or put into play in terms of different types of planting or different types of habitat creation? Is there a way to do it both? So that way there's ephemeral ponds. These are ponds where we don't think that they're going to necessarily stay full all year round, but they'll fill up and come out and fill up and come down. Like you guys get the June soons. So, there's something that in terms of the specifics of your site, there's an opportunity to have a bit more water on site to help get through sort of the July, August heat into September. And then as that water gets closer to the house, is it then pushed away from the house? So that way you're not unduly influencing the infrastructure with extra water. So usually it's for me, it's a 3 meter minimum around the house in terms of water infiltration. I won't put water infiltrate into any beds or anything unless it's further away from the house, because the house has a high value and we don't necessarily want to put that towards the house. So yeah, I would say that kind of element, especially for your site and what you're wanting to create, from what I've seen, really thinking, how can we stop that water high up? How can we keep it on the landscape? How can we sink it in? And then as you get down to the house, how can we spread it away or potentially around to that front yard, and then further down?
I've had that water issues. Actually, I had leakage into my basement here this past winter, so I've had to do some recontouring and that sort of thing, because all of the water tends to, from the neighbors as well, who are higher, the properties kind of climb up, not significantly, but enough that the water will move this direction. And so yeah, so I have to kind of account for all of that that water that's coming from off-site, and make sure it's going somewhere, not into the back corner of my basement.
Yeah, yeah. And in terms of downspouts, do your downspouts go away from the house, or do they come directly down to the side of the house?
They come down. That was the part of the problem. And so I'm kind of in the process of rerouting those. I've changed a couple of them. I've actually added a few, sort of intermediate, because I just had two. It's a very poorly sort of designed system. The way they had just kind of dumping on the far end of the house, and then all the water would, sort of move this way toward the house. And so I have to do some regrading, and I kind of interrupted that flow and added a downspout that feeds a birch tree in the front yard. And then I want to do something similar in the back, just so that the water's not concentrated in one spot on the property, but is, spread out a little bit more.
Yeah, especially with downspouts. This is something that a colleague of mine tuned me into, that so much of our work is really just writing what has been classically conventional but inconvenient, where downspouts just end at the bottom of the house and then they infiltrate the basement and then they start to unduly influence. So, sometimes if you don't need that water in the back, that can be connecting the front, or connecting the back to the front, and then running downspout on the side of the building. The other way to do it is, if you are looking at rainwater harvesting, especially in your site, because there is that gradient change, harvesting it in the back, putting in either a couple of tanks, and then having that overflow go out to the front. And this is really important. This is something that 99% of the students I tell over and over again: make sure you have a sense of where your overflow is going. Because those 1,000-liter IBC totes, which is the minimum I'll work with, and even those are so small comparatively. Like when you go through this water, assignments, you'll find it's incredible the amount of water you can harvest from that roof, because 1 square meter plus a millimeter of rain is a liter of water. So for you, in your situation and your sizing, you're going to find that you're going to get thousands of liters of water, or for our American friends, thousands of gallons of water. So you'll fill those up once or twice, and then after that you need to have overflow sized appropriately. So yeah, keeping that in mind. And then do you have like ditches in front of your property where the road is, or is there?
No, not at all. It's fairly flat. The easement is, sort of paved and just kind of more or less follows the contour. And so there's no water catchment areas of any kind. There's nothing that way, which is a bit of a problem in some way, depending on, we get some good downpour, we can get some puddling on that easement access across the property, as well as in sort of what is a planting area currently. So so I've thought about all of that, actually, because I do want to develop some kind of water catchment system, and then possibly either do a pond of some kind, maybe, and see about ways of moving that water, if I can do that, move it up to maybe the top of the site, and just sort of create some kind of a loop that way.
Yeah, usually the best way to do that on a small scale like yours is doing some sort of solar pump, so that way it's only moving water when the electricity is free, so to speak. Now, the way and how to do that, especially taking a look at your site, because you've got that birch tree and then you've got that sort of open section of lawn there, you may consider doing something like an ephemeral rain garden, where you have tiers that are dropped down. So you've got little openings that kind of like an open pond where that water has a terminal end, so that you can fill that up and it can drain down and fill that up and drain down. And then you have associated plantings at each tear depth. So that way you can have those plants that, during the winter season, during the shoulder season are going to survive, but then into the summer season, you'll be able to also allow them to die back or go into that. But a rain garden there might be of interest only because you'll need a terminal point for that water to come to.
Yeah.
Because as I'm taking a look at your base map here, you don't have, gutters or sewer ditches or storm sewer ditches as you would normally want in an urban environment.
That's kind of the rural design here, right? It's just kind of a rock pit, and that's where you direct your rainwater to, at least in new construction anyway. In this, there wasn't really anything done. Like I say, I've changed a few things to kind of help to direct the water, at least to distribute it a little bit more.
Yeah.
And so into the ground, so that it's not all just kind of soaking in one area.
Yeah.
Yeah. And so I would like to do a little bit more with respect to the back of the property and the rainwater that comes off there, and try to catch some of it and distribute it, and they just kind of figure out what's going to work that way. It's yeah, as far as the what's doable and what I can reasonably store. And then
yeah.
And so with respect to that, like the instructor was talking about not allowing water off of the property, and so that seems like an extreme idea. Like, I mean, obviously I suppose it's doable, but it's just like, for example, if I have a pond and I have like a rock pit, for example, the water is just basically infiltrating the ground, and where it goes from there, sort of anybody's guess, right? So it still makes its way presumably underground as well. So I'm just kind of curious, with respect to a pond and an overflow, even just to do it into a rock pit, is that sort of a design possibility, or is that something taboo kind of thing?
Yeah, so I think design directives and realities are always a little different. So the principle is create a prison for water on your site, so that way the majority of the water is captured and held on site, and thus is used on site and doesn't contribute to erosion and doesn't contribute to the dehydration of a landscape, which again, in principle, great. As a design directive, great. In a small urban lot where you're getting too much water that is potentially going to inundate your house or other infrastructure, it's a principle to keep and hold lightly. But when you get to the particulars of that, if you do create a rain garden or a pond, that water needs to overflow somewhere, and doing a dry well or a rock pit makes sense, right? It has to go someplace. And if all that water concentrates at the road and then overflows on the road, well, during those colder temp days and you have water runoff, you're going to have black ice in front of your roadway as you get into winter, and no one's going to like you. So every once in a while, you'll find that the principles don't apply to the specifics. It's like understanding how to cook a certain type of cuisine, and then you're getting into a specific, and the different types of food or the different types of spices or whatever availability changes how that will look in reality. So I think for your situation where you don't have either ditches or urban gutters or anything like that where you can then put your water into, because eventually there will be more than your site can handle an overflow, something like a rock pit where you can dump that water in, and it'll infiltrate, and you know that it'll enter into how close you are to the lake. It's basically going to connect with the lake. You're not going to be able to go down sub lake water and get into sub aquifer. You're not going to be able to do that. That makes good sense. Not to mention that you're doing it in such a way that it's going to move through earth, and earth generally has a purifying aspect when it comes to water. And this is one of the reasons why, spring water is so incredible, because that water is charged with mineralization and goes through a number of filtration processes of different types of earth and organic matter. So I think for you, in your situation, yeah, the idea is create a water prison at some point, but also the numbers don't lie. If you do the permeable and the impermeable surfaces in your water assignment coming up, you'll see that when your soil gets beyond what's called field capacity, which is there's still airspace in your soil, it gets to saturation. That means it cannot absorb any more water, and you get overland flow. And in your neck of the woods, that happens. You get those monsoons, there's too much water, there's overflowing, there's flooding. So you need to have a way to manage that overflow and put that overflow meaningfully into a place that might be useful for you. And if not, put it into a place that's not detrimental for others.
Yeah, yeah, yeah. We haven't had much of that. I was actually good in some ways talking about access and this sort of thing, because my thought was, just for ease of access to kind of run a pathway sort of up the south property line here, but then, kind of reconsidering that from a water movement standpoint, I'm pretty sure I would just create a runway for water to rifle down that side of the property, right? Unless I interrupt it there. So that sort of was just a good, sort of corrective idea there that got mentioned in this assignment.
Yeah, it's an interesting piece. I'm going to pull up your base map here. Maybe we'll do a little drawing. So when you get to a site like yours, it's a pretty common urban lot. There's a lot of commonality here that we're seeing. I'm going to zoom in a bit. So generally, as we're taking a look at this, what we want to do is kind of capture and store that water. So if we put a pathway in, pathways are orange in my nomenclature. So if we put a pathway in and we do something like this, well, that's perfectly on that line of water flow that you've delineated. So we know that this will basically pick up, go from sheet flow to rill to runnel, gully, and then it'll unzip the landscape. And we see this a lot in farm landscapes. So basically, looking at this, if we're going to go into some kind of earthworks, we're going to think about going crosswise across this landscape.
Right.
In some way, shape, or form. And if these are, let's say, planting beds, then the pathway, depending on where the door is, that's something that's nice to have here. I don't know if these steps down here is how you get out of the house. Is that right?
Yeah, it's access. The doors aren't indicated on that base map.
Okay. Yeah, most definitely. So, if this is coming out, then what you might think is doing something that where if you come out to the pathway, if these are earthworks, usually we'll have a pathway on the inside. And then basically that pathway kind of jogs up into the landscape. So that way, this area is never this flow line is never the same that works with that water flow line. So it can't pick up speed. A site like yours, I would be tempted to terrace only because in terracing, if you do what's called back-graded terraces, you're going to find that if you do a back-graded terrace, so if this is our cross section here, actually, there's a better way to do this. Give me one sec. Go like this, clear. Yeah, go back to here. So if this is our cross section, and if this is perfectly A to A, like so we've got A to A apostrophe, and let's say that this is the line we're working with. If we go back in, if we contour, if we terrace this landscape, what you'll end up with is, something like this. And then if this is perfectly flat, if you drop this down a little bit, this becomes a water harvesting structure. Because what ends up happening is this water, this grading holds water here. And then if we add to this a number of trees, where we usually plant our shrubs or our trees on slope, now all of a sudden we've given a place for that water to go into slope. And so if this comes up on the backside, usually what we'll do with terraces, as our terraces will actually be switchbacks. So, our terraces will look something like this as we come back into the landscape. So really nice harvesting, rainwater harvesting structure, and you get all of these different elements that you get to walk on. If you don't, and if you just make them, flat areas where, you've got a terrace and then another terrace and another terrace, then all of a sudden you have these little stepping stones that come up. But the main thing is you have to think about in any earthworks is how are you going to manage this? So normally on your scale, it'll be a wheelbarrow. So you'll be looking at 3-foot wide pathways, and you'll want gradient changes that are easy to push up. So that's why you usually go with switchback terraces, because it's easy to go back up.
I was thinking mainly that path along the south property line for, up to kind of where there's already an existing planting area. Just mainly because I can get a small excavator in there if I need to.
Sure.
Like that was kind of the idea, right? I can get like a 4-foot, I've got a 4-foot or a little over 4-foot wide space there. So a mini excavator get through that gate, and I can just kind of walk up the side of the property, at least for, sort of over what is right now the lawn area. And I can get, sort of into that little bit more undeveloped or untouched, part, and do some of that kind of terracing. 'Cause I'm, not a big fan of I don't mind some digging, but yeah, I'm not going to dig the backyard. Basically.
Totally. So, if that's the case, then just think about how that pathway might come up and level out and come up and level out and come up and level out. So that way it doesn't become a channelized water flow.
Yeah.
And then those flats could be ways, and the excavator could do that in short order.
Yeah, I thought even of maybe grabbing, like doing some kind of a catch basin of some kind, maybe even at the bottom of that space or something that, at least I can, catch some of the water and reuse it. So if there is some, because there will be some movement over the ground, because I have to kind of I have to follow more or less the contour there, because the neighbor's property and the fence line is all there.
Yeah.
So I don't have a lot of latitude in terms of without building like a retaining wall or something, right?
Sure.
So yeah, so I can do a little bit of leveling, but it's very difficult to do because of the existing property next door.
Yeah. And there's kind of a few ways.
Kind of limited that way.
Yeah, there's kind of a few ways to go about this. I don't remember. Do you have any sort of wind or issues from I just got to check your, because I think it's off. Yeah. So sort of that northeast quarter, do you have wind that comes from this way at all?
I'm pretty protected from any kind of wind.
Okay.
From that direction, just because of the hill. Once you get past my property, the hillside climbs up very steeply.
Gotcha.
And so, yeah, so I don't have much of an issue. Any wind I get will be coming across the lake, sort of southwest kind of thing, maybe a little bit from the northwest. But for the most part, I'm reasonably well protected on the backside.
Okay. Because that would have changed my thought process here. But when you take a look at this, having some kind of swale or water harvesting structure here, so that way the majority of what comes from your northeast corner of overland flow is captured. And even if you ended up putting in like an ephemeral pond here where this is captured and put into, that just means that you're going to de-water the rest of this area. So you're only actively dealing with this bottom area. And the great thing about this is you can calculate, how much water am I dealing with in this little tiny watershed if I do that? And then where can I effectively put that into? So even if it's, you keep this annual bed and you put in maybe another bed or another 2 beds, or growing areas, cultivation areas, then all of a sudden you start to use that in a really good way. And you could plant that area as well. This is the main thing about if you do use swales or if you use pathway swales, planting those with shrubs or trees, because swales really are tree growing systems, right?
Yeah.
So keeping that in mind, the thing I probably wouldn't do, only because it's so close to the house, I wouldn't necessarily put a major earthen water holding body at the bottom of this hill, only because that earthen body will soak in, and that earthen body could potentially come underneath that concrete slab and infiltrate further into the house. So again, this idea of that 3 meter, 20 meter, 3 meter, they just having a little bit of a space so that way this water actually pushes out, or it's actively used in vegetation.
Yeah.
Awesome. Good questions.
Okay. Yeah. Those are things I've tossed around. So yeah, it's good to get another perspective on that. Just helps me to think through that a little bit more. Because I did actually think that, curiously enough, that one spot that you mentioned above there, or putting that sort of seasonal pond or whatever, that seemed to be, as I was just kind of walking the property lately, like, okay, yeah, if we're thinking in terms of water, that would be a great spot for it. So to create some kind of swales. I've got some like massive trees that are back there that potentially direct some of the water maybe toward those. And then just for planting areas and that sort of thing.
Yeah, great thought.
Yeah. Good.
Awesome. Thanks, Steve.
Okay, no worries. Enjoy your day.
Yeah, you too, man. David and Shara, any questions from you folks? We don't have anything down on the books today, so it's kind of an open free form. And if not, I'll just go into the assignment this week.
Yeah, I've been super busy this week, so I've been busy, so I don't have any questions right now.
Okay, thank you, sir.
I don't have too much either. We've been kind of talking about different ways to get our artisanal well into our irrigation system, but I don't think I have anything specific.
Okay. Sounds good. We'll go through the assignment, and I'll show you an example of somebody who's just recently done it and has done just a phenomenal job. And we'll call it a day. We'll get out of here early. So we've got the assignment, and there's 3 assignments here. We've got our water survey, our watershed maps, and our site water flow analysis. I'll talk a little bit about the minimums, and this is a great assignment to kind of go the extra mile, especially as you start to design for water. So in assignment 1, we're asking what is the drinking water source, the wastewater, just to understand where that goes and if there's a reason to start to take care of that on site. What's the rainfall? So what are our records? What are our roofing materials and how old are they? The major impact of precipitation events. So this is Adria. She's over in North Carolina. And so for somebody who's rural, this will be a lot more involved than somebody who's urban. The example in the tutorial will show you quite well what to do with an urban site. But in this, she's got a private well, 50 feet deep. Love the bolded highlighting, really pulls out the information. Has a maximum working pressure of 100 PSI, 4 gallons a minute, little low, but that's all right. Pump is electric. Well water source is groundwater, and she's gone a little bit into the aquifer. She's talked about the local county's recommendation for water testing, and then the water test that was recently done, and talking a little bit about the issues with it. Again, taking a look at the recharge rate, which is important if we're looking at wells, and very important if we're taking a look at water, water infiltration. Wastewater, so currently has a septic system, pumped every 3 to 5 years, materials pumped out and where they go. And then again, taking some images, giving us the URLs and the access date, which is of course necessary. Rainfall, average annual snowfall, record 24-hour rainfall, just to get a sense of what she might be dealing with. And Steve, this is a great example for you because that record 24-hour rainfall plus about 40% is what I do, is what I size everything for. So I size all of my structures for usually the record 24-hour rainfall, 40 to 60%, depending on the climate in the area. And here they've gone into every single building, what the roof is, how old the material is. And the reason for this is asphalt shingles after about 5 years have off-gas to the point to where that water can then be used pretty effectively for any sort of watering. Here we've done the SWOT again, and then any questions. And she's made a great point of saying all the things she doesn't know, which is perfect. You know, there's a bunch of questions she's working on right now. Watershed map. Here's the big reveal. This is the answer for the watershed map, but it's also in the example. So I actually give you a full video on how to understand this watershed map. So there's no reason for that to be wrong. And then we go macro to micro. Basically what we're trying to do is get you to understand that there's major watersheds. And then as we move closer and closer and closer, there's minor watersheds, to really understand that when you cup your hand, all the water that might fall within that boundary, if you know your design site's in the middle of the palm, that's a watershed. And if that palm, let's say, is in a bigger palm, a bigger watershed, that those flow into each other. So we're trying to push you in your understanding to understand that these watersheds matter, and that in many respects we should have designed most of our geopolitical boundaries for watersheds because it creates an area of self-responsibility. This is the micro watershed, pardon me. You can see here that Adria is at the top. She's on a little null. So there's actually no water that influences her. This is pros and cons. It means she has no water to pick up from other points of land that would flow onto or off of her property. But it also means that in this area, there's actually quite a bit of contamination, and she knows that because she doesn't produce any of that contamination, there's nothing to worry about on her site. She also took some reference points of the high points. She started to learn how to read contour lines and understood all these different watersheds. So she influences 2 watersheds in her area. She was able to showcase that as well. And then finally, that micro watershed and what that looks like close up. Now, once we get to the site water flow analysis, that site water flow analysis is really taking the bird's eye view of your property and understanding of permeable and impermeable structures. Where does that water flow and collect, and what can we capture in terms of total catchment and in terms of total flow? We'll talk a little bit here about what's called the coefficient of runoff, and that just means that there's a certain percentage of water that will fall on different types of material that, because of that material, will either evaporate or will be absorbed into that material. And so you won't get a full 100% of that water that falls onto that surface that flows off of it. So when we take a look at organic matter or forestry matter and different ecologies, they'll absorb quite a bit. So that runoff coefficient can be as low as 12 or 15%. When we take a look at metal roofs, it's around 95, 96%. And the only reason for that is that that first rain will usually have some evaporation, or there'll be some slight absorption into the material. So I might have said this to her in her in that conversation, that there were other elements there for her to remove, but there's a lot of material here in terms of really taking a look at your site and understanding your site and understanding the different elements. So for Steve, which is a great example to come back to, Steve has a couple of downspouts that are a little off-centered, or they're not at the corners of the house. So looks like we've got 1, 2, 3, 4. And so while Steve may just do the left and the right-hand side of this house, he'd be better off to take a look at this from a perspective of what actually flows into each of these downspouts, and then calculate those areas. So what this might look like is, and again, we're not using green or blue, so that might look like this area flows into downspout 4. This area flows out down into downspout 3. This area flows into downspout 2. And this area flows into downspout 1, something like that. You'll have to go out, Steve, and take a look at it in real time and see what it looks like. Oh, that's the same color. Let's try again. But the reason why we do this is because the water coming down to the downspout is usually the more useful element of this. We really want to understand what that looks like. Does that make sense to everybody? Any questions about that? I just want to make sure that's clear before I move on.
Yep, clear.
Okay, cool. So I just noticed that Adria actually did a addition to her slide. So I'm just going to bring that up. Thanks for the feedback. So we're going to bring this up, and Adria did this in spades, and this is one of the reasons why I'm showcasing this example. I have been brought tea. Thank you very much. How lovely. Okay, so we're just going to let this load here. It's going to take a moment. And into Adria's site. Here we go. Cool. So here what we have is we've got our major site and our major elements, and then we have all of these different buildings. So what she's done, which I suggest everyone do, is go down to the specific areas of each of these. So she's got these different spigots, and she's also put in the gutter high point, which is brilliant. And she's also shown the gutter flow direction. She has some complex roofs, and she understood that each of these roofs is going to be a different flow down to these different downspouts. So she basically did FR1. So here we have FR1, FR2. FR2 color coded it, did the square footage because she's working in imperial. If you're working in metric, you would do this in metric. Again, don't take this course to learn a new measurement system. And then again, here she's done the same thing. So where runoff concentration is, because it doesn't necessarily have downspouts, but if she did put them in, she could know where they were. And she's done this for all of the buildings. So really pulling out these buildings and showcasing all the different areas. And again, because these are areas that don't have downspouts, she's just theorizing that these could be 4 areas. And then finally, that small carport and large carport. Then she's gone on to site water flow gross calculations. So bringing in what is that weather, bringing in the access, where that's from, bringing in the access date, and then working through the calculations that were given. So what is the area and square feet? What is the rainfall? And then what is the gallonage? So here we've got 3.6 mega gallons. So 3.6 million gallons of water that falls onto the total site. Now, the one thing that I recommended she do, because she actually just submitted this was a little late, is I would have kept the coloration from these elements here, and I would have made the entire outline of this a different color, so that way each of these, because she's reused these colors, so that way, let's say the outline's red here, same colorage, and then the outline here is, let's say, pink, because there's pink flowers here. That would be the outline. And then what she could do here is she could do that on each one. So basically in the gross calculations for impermeable surfaces, she's done FR1, she said the material, what is the area in square feet, and she's changed this to showcase the unit she's using. What is the yearly average rainfall, what's the maximum, and what's that runoff coefficient? So again, there's, if you go back to our site here, you're going to get to, there's a couple of runoff coefficient tables that you can utilize. This is a general rule, or general rule. It's not perfect. You always have to work with it a little bit. And then she's given us calculations for what is the yearly runoff volume and the 24-hour runoff volume. You've noticed she hasn't put in ditto marks for anything, which I highly recommend not doing. We want to have a full and complete table. And then she's done farmhouse total. And then she's done this for each of her buildings, which I recommend. So she's done each of these. And she probably even could have, just to keep visually the visual language, she could have brought in this image and as a small image and just, you know, put it up in the top corner here or something, especially in these other ones where she's got some space. If you're doing this for clients, they love those little images to help them visualize everything. Then she's done permeable calculations, again, which I highly recommend. She's gone into taken her soil data, and that soil data has then been able to give her a sense of what that runoff is again. That soil data material also is in that runoff coefficient sheet, so it's easy to plug in your numbers and then come up with what that looks like. Finally, she's done gross calculations for everything. So taking a look at the total permeable and the impermeable, she has all of the information there, and then has done, again, a SWOT analysis with bolded highlighting to pull out a lot of the information. This is that piece I was talking about before. We're considering how polluted my neighborhood and local waterways are, the potential for groundwater pollution from local businesses, residents, and motorists. I think it can be considered a strength of the design site's micro watershed is largely self-contained. There's only one small area of the neighbor's property to the east that influences a small portion of the site in the southeast. Does I have more control over the pollutants entering my groundwater, the water I drink and use to grow my food, and the risk of flooding on the site is almost nil. So this is a really well done, really well thought out area and material. And now that she has these different areas, she's also able to understand this area better. So I might even, if this were and I was working on this site, what I probably would do, and we do this all the time in keyline design, where we'll take the ridges and the valleys and we'll create these little land units. This is something that P.A. Yeoman did, which was really quite intelligent. So what you do is you'll usually use red for your ridge line. So ridge line usually comes through, and I'm just going to go off of her ridge line here. There's a couple other ridge lines here. So there's kind of a ridge line that comes up this way. You can kind of see that it's coming out a little bit, but that's about it. And then this is largely the same, but the road is acting as a valley. So the road has a valley shape and form to it, because that water is going to divide on either side, because mostly roads are crowned, so they become ridges themselves. So that means that I would put that as a ridge. And maybe I'd put the sides as gutters. So this means that we have 1, 2, 3, 4, 5 land units. So how that looks is we'll usually use orange, and we'll kind of draw these out. I usually do this in Google Earth Slides, or no, Google Earth Pro. The only reason is it's really easy to do these shapes, and those shapes automatically are calculated as areas. So this would be L1, land, or LU1, land unit 1, land unit 2, land unit 3, and land unit 4. Now, why would I do this? Because if I work with, let's say land unit 2, because we did a bunch of work together on this site, I know the total water flow off of this area, and I also know what my capture might look like. I can also start to calculate if I want to take building 5 and put it directly into landscape instead of downspouting it or guttering it or anything else. If it just comes off and hits these bushes, then it's doing its job. And doing in-ground plantings can be a great way to uptake that water that's already there. Steve will notice that I said never infiltrate water 3 meters within a building. I totally agree with that. But at the same time, if you don't have the money or the time to put in gutters, putting in plants can be shallow rooted plants can be a great way of taking up that water. And sometimes in Kenya, we would do this quite a bit. We would do in-ground gutters. So we would have a building, and we would have the ground, and we would basically dig in to the ground like so, because the roof would come off like this. And then we would take this in-ground gutter, we'd usually line it with bricks, and then we would take it off, and then we'd usually plant around it as well. Only because there's no gutters there, and you've got to use it somehow. So generally, rule of thumb, 3 meters, do not infiltrate water near the house. And so in-ground gutters is a way to, if this was here, to take that water away from the house. So that way the foundation is taken care of. Respected, I think is the word I want to use. So that's the water flow assignments. Any questions about the water flow assignments from anybody?
That's really helpful and a great example.
Awesome. Yeah, she did a phenomenal job. Okay, folks. Well, if there aren't any other questions, I'm just going to quickly chat about the break, and then we'll go about our merry way. So break timing, as you folks know, we've got week 5 assignments, the water assignments due June 6th. We have a break then between there and June 20th for assignment 6. So we basically have a week and a half break where I won't be marking and you won't be submitting. If you want to do your peer reviews, you're welcome to. I just won't be on marking anything beyond that week of assignment that's due. I'll be marking that week, and then I'll be taking that next week and a half off. So just food for thought there. As usual, any questions, any comments, any queries can go into the Q&A doc. And any questions about the water assignment, if you're going through it, feel free to reach out. Some folks can get a little frustrated because there's a bit of math involved with this, and we haven't had any real math in the course thus far. But remember, this isn't high school. This isn't university. I want you to get 100%. So I'm not grading for you to fail. I'm grading so I can point you in the right direction. So if you do need any help, feel free to reach out. Happy to have a quick one-on-one or just answer a question and go from there. Any other thoughts, queries, questions, comments, quandaries, quotations?
For me.
Thank you, sir.
Yeah, I'm good. Thank you.
Awesome.
Excellent.
Awesome, folks. Well, thanks so much for showing up. I fully expect that we'll see less and less people on our Mondays as the summer goes on. So it was nice to see everyone show up. Just remember, if nobody shows up by 15 minutes after, I will pull the plug and there will be nobody here. So just a reminder, if you do come 15 minutes after and I'm not here, it's because nobody showed up for those 15 minutes. And as I was teaching in university before, that was my rule. So it is still the rule today. Thanks so much, and we'll see you in the next one. Take care.